Okay, good morning. Today's we are seeing about the biogas technology. In this chapter contains some introduction about biogas technology, production of biogas, that properties of biogas, parameter for obtaining maximum biogas production, biogas utilization, and economical and environmental aspects of that biogas. In that first one, let's see the introduction about some biogas technology. Biogas refers to a mixture of different gases, mainly methane and carbon dioxide, produced by the microbes from organic matter in the absence of oxygen. In this, uh, you know about biogas technology is primarily based on fermentation of cellulose rich organic matter under anaerobic condition. The methane, that means CH4 producing bacteria, becomes more active after the creation of anaerobic condition. Anaerobic condition means no air is placed in that digester of biogas. For burning of biogas, it is necessary that CH4 content should be more than 50%. Complete knowledge of process of CH4 production include chemistry, physiology. Physiology means function of living organism and their parts, biochemistry, microbiology, and bacteriology. Okay, the condition under which cattle dung, organic waste versus weeds, etc. will produce CH4 can be understood through chemistry of fermentation. In this biogas, there are some composition like CH4, CO2, H2, H2S, NH3, and this composition CH4 is about 55 to 65%, CO2 is nearly about 35 to 25%, H2 is about 0 to 1%, H2S is about 0 to 3%, and NH3, that means ammonia, it's 0 to 0.5%. Likewise, in this introduction, how production of biogas takes place in a digester, we have seen four types of reaction is there, which is hydrolysis, acidogenesis, acetogenesis, and last one is final is methanogenesis. In hydrolysis, there are complex organic molecules to a soluble, that means any substrate for use for a biogas production which contains a organic molecules, and in hydrolysis process the complex organic matters containing carbohydrates, protein, fats. See the cursor, you have seen cursor on the screen. In complex organic matters containing carbohydrates, proteins, and fats. Then, after adding these substrate means biogas production material, the soluble organic molecule, that means sugar, amino acid and fatty acid, which is converted into volatile fatty acid, that means in acidogenesis small organic molecules. Which one is a small organic molecules? Sugar, amino acid, fatty acids. These are converted to a volatile fatty acids. Okay, after that, in third stage acidogenesis, these volatile fatty acids will convert to a acetic acid and carbon dioxide, that means CO2. This process is a acetogenesis, and after acetogenesis final one stage is a methanogenesis. In methanogenesis acetic acid converts a CH4 and CO2 converts a CO2, that means CO2 nothing change, final conversion to a acetic acid to CH4. This is a methanogenesis process of biogas technology, which includes these four mechanisms: hydrolysis, acidogenesis, acetogenesis and methanogenesis. Hydrolysis means which contains complex organic material. Acidogenesis means simple organic molecules converted to the fatty acids, and acetogenesis conversion in acetic acid, and methanogenesis finally conversion of acetic acid to a CH4. Okay, there is a some feedstock useful for, that means material useful for biogas production, which is energy crops, animal waste, industrial waste, night soils, agricultural waste, municipal solid waste, kitchen waste, and sludge from wastewater treatment plants. These are the material used for a biogas production. After that, some types, we can see the types of biogas and all mechanism. Also in last year, renewable powers, renewable energy last year course, which is 243. Okay, this biogas plants types containing fixed dome type and floating gas holder biogas plants. In fixed dome, there are a Janta biogas plant and Dinbandhu biogas plants. Means their dome is fixed in a ground or floating gas, that means Khadi village industrial commission model, and Ganesh biogas plant. These are the floating gas holders plants. In this, we know floating means this word says about how its holder float on a digester, and some components of biogas plant, which is mixing tank used for the mixing of substrate material, means, and inlet pipe connected to the digester. In digester, there is a anaerobic condition will be maintained, and after digester material in a digester, then anaerobic reaction takes place, which is hydrolysis process, acidogenesis process, acetogenesis, and finally Its methanogenesis process will occur in the digester. Then gas holder, that means dome, store a gas, and with this gas is out pass out through the outlet pipe to a distribution pipeline, and manure pit, which is uh, digested slurry stored in a manure pit. Okay. Let's see about some factors affecting biogas productions. Which types of factors are affect for biogas production, or for optimum production of biogas? That means how to increase biogas production. These also containing same parameters like temperature, pH, nutrition, concentration, retention time, total solid content of the feed material, uniform feeding, mixing or stirring, and plant design. How plant will be designed. Optimizing means how to increase biogas production. These parameters and factors affecting parameters are the same. In that, uh, we know about how biogas plant works. Wait for a minute.